Okay, finally. Huh. Before I start the lecture, any of you have any questions? No questions? Yes.
So, it looks like when the extra credit last hour, it might say not my grade or something.
I'm going to add that manually to your grade and then eliminate that extra credit. So don't worry about it. Extra credit just is going to help you. I did that for my one-on-one class, but for this class, I still didn't have the time. But don't worry about it. Extras are extra, so it won't drop your grade. Any other questions? Okay. So just quick reminders. One thing about the course evaluation, as I said, evaluations are good for me to improve my performance and also for my colleagues to see what is good to do, what is not good to do, I guess. And also if you have like suggestions to improve the class, and also if you saw something that you enjoyed, also I appreciate the nice comments if you have any, because I tend to get like negative comments, and students when they don't like it, they just like attack me with things that they don't like, and it just gets me down because I care. So if you also see something, so feel free to just criticize and then write the things that you think should be improved. And also feel free to mention things that you liked, so kind of like encouraging me as well. The other thing about, and then the deadline for evaluation is on Friday, so I appreciate if you can make some time to do it, I'll appreciate it. And also extra office hours. If I schedule office hours this evening, how many of you would attend? Okay, so what time do you guys prefer? And usually, guess it doesn't recognize my pen. Okay, so do you guys prefer, let me just write this, I guess. 4 to, I guess I can do 4 to 5, 5 to 6, 6 to 7. How many of you, based on your schedule, will attend 4 to 5? Yes. Or like 5 to 6, 6 to 7. Which time do you prefer? 6 to 7? Okay. So what about tomorrow? How many of you can make it to any of these hours tomorrow? Okay. So what I'm going to do, I'm going to write this. So for today, which is Wednesday, and I kind of like it when the date matches Wednesday, So in Farsi, instead of saying Sunday, Monday, Tuesday, Wednesday, we call it Shambe 1, Shambe 2, Shambe 3, Shambe. So maybe for you it wasn't making sense, but in Farsi, Wednesday has 4 of those, so it matches. Anyway, so today, for Wednesday, 4th of May, I'll have office hours 5 to 7 p.m. And then I'll do the same for tomorrow, Thursday, which is 5th of May. And hopefully I'm not writing this confusing, 5 to 7 p.m. So today and tomorrow, basically. Feel free to stop by. And as I said, for like this, tutoring with myself or tutoring at library or any extra resources that you get, for 1 hour of that, I add 5 points. So if you're on the edge of getting an A or B, or you want to secure your grade, or just for getting tutoring, just feel free to stop by. And I try my best to prepare you. And that is that about office hours. And then Friday, I guess, during the class, I talk with you to see if anyone is going to show up. Because if no one is going to show up, I just don't want to sit at my office or be obligated being there. Okay, so this is course evaluation I talked about, and I realized when I wrote course evaluation, I forgot an A, and I was, I want to correct this, and I realized it was just in the online version. So anybody who watches the video on YouTube see that I misspelled evaluation, but I know how to spell that one. So anyway, so course evaluation, office hours, and that's all I needed to talk about before going through the exam preparation. If no questions, I just start. And I have so many things to talk about today. Try to go fast, but somehow that you understand what I'm saying too. So this is kind of like the building block of our course. Okay, so if you still have issues or like difficulties remembering which one was, or what is methane, ethane, propane, which one was which, it's most probably you're struggling naming compounds for all the chapters. So make sure to know that when you have one carbon, you have like, METH, like methane, like, right, ethane, propane. And when you have an alkane, right, you have CnH2n plus 2. This is the general formula. Also remember that. And when I review chapters 3, I talk about alkenes and alkynes, but for now, remember these, okay? So pentane, propane, knowing that when you have prop, right, you have 3 carbons, or pentane, you have 5, and make sure to know this table. Okay, I asked you one question in exam, which of the following is heptane? And for instance, I give you this, that, and as long as you know which one was 7, you will be fine. And here, now that we have this, we call that, if you remember, abbreviated structural formula, right? So it basically still tells you how these atoms are bonded together, but instead of writing carbon and having 4 bonds around it, which just takes lots of my iPad space or screen space, or like in your paper, instead of that, we just write CH4. So if you write, for instance, CH3, CH2OH, you bond these carbons together, and if you have double bond between them, if you have an alkene, we'll specify those. If we don't specify something between these, it means that all are single bonds. And then you attach hydrogens. And if you have anything else attached here, and in the next slides I have chlorine, bromine, or we talked about ethers, right? Or we have like benzyl group or whatever. So we wrote them. But if you don't write anything else, we just fill them out with hydrogen. Does that make sense? So if I give you an exam, something like this, in each of these points, you put a carbon, right? As you remember. And then you count the bonds. And as we said, carbon has a valence of 4, so it should have 4 bonds. So it has already 1 here. We put 3 hydrogen, meaning that it formed bond with 3 more hydrogens. And then here you have 2 bonds, right? 1, 2. You put 2 here, 2 here, 2 here, and so on and so forth. And then you have 3 here. But again, if you don't know this slide, make sure to know, because most probably you cannot get other things. Any questions? Good. And also remember that alkanes are saturated hydrocarbons. So when we have only single bonds, we call them saturated. If you have multiple bonds, meaning double bond or triple bond or combination of those, we call those unsaturated hydrocarbons. Also, I tried my best to copy paste all of the materials that you need to know for your exam. So kind of you have like an online version of the book. And please don't distribute this anywhere. Don't post it online or something. Just have it for yourself. As I said, at this point, I don't want to force you to get the book if you don't have already. So I try for you to have all the resources, but just keep that for yourself. Don't distribute it in any way, so we won't be having the copyright issues. But for the sake of your exam, I included everything. I tried, maybe I forgot one question or something, which I don't think that happens. But if you just study these slides, well, you should be able to answer all the questions in the exam. And I try to include everything. But this is my point. Also read the definitions, because it sucks if you have answer a really difficult structure correctly and name that correctly, but just saturated, unsaturated, you get that question wrong, right? Okay, and let's study the definition. Next slide. So do you remember when we were talking about butane, I told you should have the hand feature. Okay, I told you that we have normal butane, and also we have isobutane. Do you remember what was the difference? Exactly. So if you don't have any branch, you call that normal. If you have a branch, you call that iso, or not normal, for sure. Okay. And here you have also examples that I want to make sure to go over all the materials. So just make sure to solve the questions, by yourself. So for instance, which of the followings are alkanes? So is this one alkane or not? Exactly, because if this number of carbons is 7, here we should have 7 multiplied by 2 plus 2, right? So it should be C7H16, right? What about this one? Exactly, this is an alkane. What about this one? It's not, right? What about this one? It is, right? Because 27 multiplied by 2 would be 54. 54 plus 2 would be 56. Okay. Any questions? Okay, now naming compounds. And if you learn or kind of like review naming for kind of like sideways, yes, you get the point. Okay, if you learn it for alkanes, it would be similar for alkanes and all other compounds that we studied in this class, but we just add like simple rules to them. But this is like the main procedure. So the first thing that you do, and I just go over it really quickly so I can cover the whole chapter too. So what you do, you find the longest carbon chain, okay? And remember, that is like the first rule, especially if you have only alkanes, only single bonds, right? So the first thing that you do, you have like the longest carbon chain, okay? And the next step, I guess I go to the summary slide here. Okay, and remember like the alkyl groups, and we talked about them briefly in the last class, that they were free radicals, right? Because they had odd number of electrons. So if you have any alkane and then you remove a hydrogen, hopefully that makes sense what I'm writing, you get an alkyl. So if you have CH4, C2H6, or like C3H8. So what is the name of this?
Methane.
What is it? Methane, exactly. What is the second one? Ethane, right? What is this one? So if I remove a hydrogen, CH3, C2H5, and C2H5, you can denote it right this, right? You can write it CH2, CH3, right? So pay attention to that too. What is the name of this? Methyl. And I should go a little to the left to have more space. What is this one? Ethyl. What is this one? Propyl. Okay, so make sure knowing these well as well. So saturated substituents containing only carbon and hydrogen are called alkyl groups. And as I said, you can write it as like this CH3 or like abbreviated formula, or you can just write Me as like metal that is bonded with something else. Any questions? Okay, this is like the summary. And as I said, just make sure to read everything. I'm just trying to be as fast as I can. So the first step is to finding the longest chain. And what I do, I give this structure in exam, and then I put like hydrogens here, as I just told you how to put number of hydrogens, right? And then I call this compound something like butane, right? So if I want to name this compound, and I'm reviewing, but before I go through the next slide, can anyone tell me what is the name of this compound? If I name it incorrectly with this system, Does that make sense? So what is this one? C2.
2 ethyl
Uh-huh.
butane.
Exactly. So I'll give you this in the exam, and I say, is the following name correct or incorrect? Or is this written correctly? Yes or no? So what you do in this type of questions, so you write 2-ethyl butane. So what you do, first you write butane, right? And then name it 1, 2, 3, 4. Carbon number 2 is attached to ethyl, and then ethyl, you remember, is C2H5, right? And then after writing the structure, you look for the longest chain. This is one of the things that you do. And then you realize that, okay, this compound has 1, 2, 3, 4, 5 carbons in the main chain. So this name is incorrect. Does that make sense? So longest chain, and most of the time, one of the things that I ask in the exam is like, was that the longest chain or not? So make sure also when you study this, you can do that as an example to write the incorrect name of the compound and then write what is the correct name. Because it's really possible to say, to be fair or like easier towards you and also be easier on me, I just open these slides and then just write the questions from these. So make sure to study them well. So the first step is to finding the longest chain. Any question? And just feel free to ask questions at any time. The second step, I'm kind of zooming this, is to name the carbons, right? And then you name the carbons so that you reach the branch sooner. So if you name left to right or right to left, and then you name the branch number should be the lowest, right? So here, for instance, carbon number 2 is attached to a methyl group, right? But here, if I name it, the other direction, it would be 1, 2, 3 that is attached to methyl. So we don't want that. Again, feel free to write the wrong name of this and then kind of like try to go from this to that. Does that make sense? Also, the ones that are not correct, try to write the name. So if I give that in the exam, you know how to get from the wrong name to the correct name. Does that make sense? And the other one, the other rule is that if, there are 2 equally long continuous chains, select the one with the most branches. Remember, so this rule, we didn't encounter that much. But if you could have like 2 main chain, we always want to have more branches if that's possible. And the last one, second to the last, is that if you could go left to right, so here left to right, my carbon number is 2, right to left is also 2, you look at the third branch. You also want to reach the third branch sooner, so that third branch has the lowest number. Does that make sense? Good. And again, these names that are not correct, so these are, I'm going to cross because these names, I guess, these are wrong, but also study them. And finally, if everything else that we said was the same, the location was the same, the carbon number of the third branch was the same, and everything, we go alphabetically. Okay? And regardless, when you're writing the names on paper, for instance, if you have methyl and you have ethyl, you write ethyl first. Just writing in the paper. Okay? Does that make sense? Okay. Let me go back. Okay. So I go through this example really quickly too to make sure that we know this. So if I ask you to name this structure, what is my longest chain? Exactly. And should I go left to right, naming carbons, or right to left? Exactly. 1, 2, 3, 4, 5. And what are CH3s? I just talked about them. Methyl, right? And when you have 2 methyl we call that dimethyl. So when you have 2, we call that di. When you have 3, we call that tri. And then we call that tetra when we have 4. And I don't recall we had any example that it had more than this. So I think if you know these, it would be good. So you call that 2 and 2 dimethyl because you have 2 methyls and both of them are attached to the carbon number 2. And before I highlighted this, you could see that the name is pentane because you have 5 carbon in the main chain. Okay, so I may give you this structure, very same thing, kind of like this 1, 2, 3, 4, 5, and here I write CH3, and let me write this too, 2, 2, 3. If, and I consider this being my main chain, for instance, and I say 2 methyl, 2 propyl propane, something like that, and I say, is the following name written correctly? Would that be correct or false? You should look for the longest chain. Okay, so this name is incorrect. But as I said, any question that you see, also ask yourself how I can ask a question from that. And also go through these examples. As I said, any of the things that I mentioned in these last few sessions, it's really possible that you see on the exam. Questions? Okay, so we talked about alkyls, which were basically alkanes that we removed the hydrogen and they were substituent. But it's possible when we name the compounds, right, you can have other substituents as well. So this is kind of like the summary that I just talked about. So your book had that here as well. And as I said, if you have like the propyl group and isopropyl groups are 3 carbon groups attached to the main chain by the first and second carbons respectively. So also make sure, and I think I asked that in your exam or like your quiz, you had isopropyl somewhere. So make sure to know the difference between propyl and isopropyl. As we said, if you have like a branch or the structure, is not normal alkane, it would be, isoalkane in a sense, like isobutane or like other compounds. And also here again, this is a summary of what I just talked about. In the previous one, you had like propyl, so you had like CH3, CH2, CH2, and this carbon, the last one is basically, if I put these CH2s here to demonstrate this one, the last one, we eliminated this hydrogen. But if you eliminate the and here, this is kind of like more explanation, that you can have, depending on which carbon, in the sense of isopropyl and propyl, depending on which carbon is missing the hydrogen, it would be propyl or isopropyl. This one, basically, if you eliminate this one, that would be isopropyl. Okay, and for the case of butane, butyl, sec-butyl, tert-butyl, and isobutyl. We talked about that in detail before. Just to mention that really quickly, if I have my 4 carbons and I don't have any branches, what is this? Exactly, butane, and specifically normal butane. It doesn't have any branch. But if I have 1 branch and I put that 3 here, 3 here, 3 here, 1 here, what is this one? Isobutane, okay? And remember, and I always tell the students, anything that I can remember, you guys can remember, okay? So to knowing the difference between butyl or N-butyl, you can also write N-butyl for butyl, sec-butyl, tert-butyl, isobutyl. In order to remember, just do the following. These two, N-butyl and sec-butyl, these two are driven from normal butane. We removed 1 hydrogen from this structure. Okay, but if we remove 1 hydrogen, I'm going to change the color. If we remove 1 hydrogen from isobutane, we get isobutyl and tert-butyl, okay? And depending on which hydrogen we remove, if I remove one hydrogen here and change this to 2, that would be butyl. If I remove one hydrogen from here, one of the carbons that are attached to 2 hydrogens, that would be sec-butyl. And the reason that we call that sec-butyl is that is terrible color that I chose. Because this carbon is attached to 2 other carbons, the one that I removed the hydrogen. And here, if I remove this hydrogen here, now this carbon is attached to 3 other carbons, so we call that tertiary butyl or tert-butyl. And if I remove one hydrogen from the ones that they were like 3, that would be isobutyl. And in your exam, to make sure, because sometimes I give the structure like the one that was in your exam, that you had like sec-butyl, you know, if sometimes when you see, and this is just like an example that I'm writing, it's not sec-butyl necessarily, but what I'm saying is that sometimes when you see broken line or like you see a structure that you're not familiar, it may get confusing. What you do is that see what your compound is attached to. What I mean is that if you have a structure and you're not sure if it's sec-butyl or like butyl or isobutyl, remember, first of all, you can write the structures yourself, as I just mentioned how, and you can see that you have this carbon that is attached to the rest of your compound, because this is how we attach this substituent to the rest of your molecule, through here, right? Through this bond, because the rest are, the carbons are filled, their valence is filled, right? So we attach them here. You see that this carbon here is attached to one CH3, right? And then attached to one CH2. And then here, after that, you have CH3. So if that is the order, you have sec-butyl. But, for instance, here, for isobutyl, when you just look at this structure, you should have your CH2 attached to CH, and that CH attaches to 2 CH3s in order to have isobutyl. Does that make sense what I'm saying? So in exam, see here, if you have like the rest of your molecule here, just look at here and then see if you have this carbon attached to CH2 and then CH3, and then you have like another CH3 attached to CH3. So if you remember that order, it helps you to see if it's sec-butyl or tert-butyl or isobutyl or like only butyl. Good? Question? And I'm going to give you at least one question that has one of these butyls in them, because at this point, I talked about them, I don't know, I feel like maybe half an hour of the class time, or like maybe an hour overall. Questions? Okay. And anything that we talked about, naming alkanes with alkyls, you can also have halogens, right? And as you remember, if you have chlorine attached to your alkane, we call that the substituent chloro, right? Instead of methyl propane, we can call that, if you have Cl, we call that chloropropane or like chlorobenzene. Next when we talk about those things, okay? And when you want to write them on paper, depending on if you have methyl and bromo, you write bromo sooner because alphabetical, you know. Does that make sense? Good? Okay, and this slide is really similar to what we talked about, so make sure you study them, because as I said, what I do, I write, you know, the name of this compound, you know, and I ask you what is the structure. So all of these are good resources for you to study. So physical properties. So we talked about intermolecular forces, and we talked about some properties such as boiling point, right, or solubility. Do you remember when we talked about hydrogen bonding? And we talked about that several times during different courses of the class. What is hydrogen bonding in the sense of intermolecular forces? Can anyone say, so you hear some other voice?
A hydrogen attached to highly electronegative.
Uh-huh. Exactly, a hydrogen attached to a highly electronegative element. And we talked about those elements are nitrogen, oxygen, fluorine. So if you have hydrogen that is attached to nitrogen, oxygen, fluorine, you'll be having hydrogen bonding as intermolecular force. And remember, if I tell you, give you this and say, is the following statement true or false? This bond here is an intermolecular hydrogen bonding between hydrogen and fluorine. True or false? That is false. When we're talking about intermolecular forces, we mean you have one HF and another HF. That is between the molecules. This is a covalent bond. Okay? This is not the hydrogen bonding that we're talking about in the class. Hydrogen bonding and in general intermolecular forces are between the molecules. So this would be hydrogen bonding. Okay? So both of these should be attached to whether oxygen, nitrogen, or fluorine. So if you have HBr, and I say, is the following statement true or false? This is a hydrogen bonding. False. It should be oxygen, nitrogen, or fluorine. So just having hydrogen is not enough. Questions? And again, read all this slide. I'll put that for you to study, but I'm going to pass through it to make sure to cover other materials as well. Okay, and this is kind of like summary of what we talked about in chapter 2. Okay, so if you have more branches, okay, and if you see that compared to this one, if you compare these two, this one is more round structure, and hopefully you can read what I'm writing. So when you have more branches, your molecule becomes more round and the surface area decreases. For that matter, the boiling point decreases. Okay, does that make sense? And if you have like more, you have like a long chain, so these three structures, they have like similar number of carbons, so their mass or weight is like similar, but the difference is branches. So having more branches decreases the boiling point. And also, if you have like, for instance, if you have methane, right, ethane, propane, all of them, they don't have branch, but just we compare the number of carbons in the main chain or their mass or their weight. When the number of carbon atoms increases, the boiling point increases. So what I do when I'm writing your exam, I just say which of the following has the highest boiling point, okay, or which one has lowest boiling point. So as long as you comprehend the rules that I talked about, you can answer the question well, okay. And we talked about hydrogen bonding. We had two other intermolecular forces. One of them was London dispersion or van der Waals interactions, and that is when you have non-polar molecules. Non-polar. For instance, nitrogen molecule, right? Or CO2. At this point, I'm not going to talk about in detail why, but CO2 is also non-polar because of their geometry. Although each of the bonds are polar, the molecule as a whole is non-polar. And also all your alkanes. And we talked about this before, that carbon and hydrogen, they have different electronegativities, but we consider them being close enough. So also these are non-polar. Okay? And hydrogen bonding, I told you how to distinguish when we have hydrogen bonding. Anything else would be dipole-dipole, like water, like BF3, or any other compound that, HCl, HBr, that are not non-polar, or they don't have hydrogen bonding, they would be dipole dipole. Any questions? Are we good? Okay, and here you have like, again, you can, you see that you have two structures, and I say, is the following statement true or false? Pentane has lower boiling point than 2,2-dimethylpropane. True or false? False, right? So as I said, any question that I ask you or any slide that you see, ask yourself how I can ask a question from that. And that can be applicable to all your other classes too. Anything that you study, make sure that you comprehend well. Okay, so I'm going to go to this summary slide here. Okay, before that, I talk about cycloalkanes. So cycloalkanes were alkanes that they had a ring, right? So if you have like 3 carbons, and in each of these points, I can zoom this a little, you put a carbon, right? So this would be cyclopropane, this would be cyclobutane, this would be cyclopentane. And if you write the formula for these, it won't be exactly CnH2n plus 2. Okay, so don't get confused. But still, we call them cycloalkanes. They are still alkanes, but they are cyclo, okay? So, and then this one. And cyclohexane, make sure don't confuse that with benzene. As we said, benzene, I'm going to talk about that on Friday. That benzene, they have like double bonds that they alternate. So make sure that don't confuse that. And then cycloheptane and then octane, okay? And let me go to the next slide. When you want to name them, if you have only one substituent, you don't have to write 1 or 2 or whatever, because even if you put this CH3 here or here or here, all of them will be the same, okay? But if you have more than one substituent, you should name them. And you want your substituent to have the lowest number possible. So for that matter, we call that 1 and 2. We don't call that 1 and 5. And when you start, naming them, you should whether go counterclockwise or clockwise. You cannot, I guess this is intuitive, but you cannot name them 1, 2, 3, 4, 5. Does that make sense? You just should go to one direction. And that was kind of the same when naming branches too. You start somewhere and then you go all the way to the other side, whether left to right or right to left. And when you write them, so for instance, here you have ethyl and methyl. So you start naming from ethyl, that is alphabetically prioritized. Does that make sense? And also, again, also study the wrong names, because I say, is the following name true or false? And if you study the slides and if you study for the test, your test would be really easy. But if you don't, it can get harder. Yes?
So for 2.12b, would you have to do 1,1 dichloro, or would it just be dichloro or cyclopropane?
You should say 1,1, and that is a great question what your friend asks here. Should I say 1 and 1 dichloropropane, or can I only say dichloropropane? So the answer is that you should write 1 and 1, because I can give you this structure. What is that?
Okay.
That would be 1 and 2 dichloropropane. And that is a really great question. It inspires me to write a question for your test. So do you remember you had really something similar to that in one of your exams and also quiz, that I told you which of the following can have more than one compound or represents more than one type of compound. And one of that was dichlorobenzene. So dichlorobenzene, again, because we had depending on where you put those two substituents, it can be methyl, ortho, para, so it represents 3 compounds. So if I ask you the same here, which of the following represents more than one type of compound or more than one compound? And I say dichloropropane. So that would be the answer, because you can have 1 and 1 or 1 and 2. And that would be all that you can have, right? Because even if I put it here and consider these two, that is the same as these two, Anyway, great question. Any other questions? Okay, now cis and trans isomers. So we had like different types of isomers. One type was cis and trans that we had here. We had also in alkenes that I talked about in the class. And again, if you have a ring, and when I demonstrated that in the class was like, if you have like, you consider my hand to be like the ring, one of the substitution would be top, right? The other one would be down. That would be trans, right? Kind of like this structure here. But since we write them on the paper, it's just more difficult to visualize. But if both are on the same side, it would be cis. Okay? And we also had in alkenes that I'm going to talk about in the next class. But again, make sure to study these, you know. As I said, it would be, you just feel so bad if you see something that was just written here and, you know, you can't answer in the exam. And also go through these examples, you know, and make sure, you know, to ask me if you have any questions or if you want to check your answer or anything else. And this was kind of like the summary slide that I'm going to just talk about that right now because that is all the time I get. So we had like structural isomers or constitutional. Okay. So if you have same chemical formula for two compounds, but the structures are different. When you write them on the paper, one of them attaches to oxygen, you know, one of your carbons, the other one, the carbon attaches to the other carbon. You know, and you have like more explanation in the slides, but as of right now, remember, if you have different bonding patterns or the same chemical formula, different structures, that would be structural or constitutional. And if you have, when you write, the chemical formula is the same. So isomers in general, they have the same chemical formula, period. So that is the same for all of them. But for structural, the structures are different. For stereoisomers that we had two different types, one of them conformers, the other configurational. So we have like the same bonding pattern and just the 3D structures are different. Does that make sense? So if, you know, you can, by rotating around the single bond, you can convert one structure to the other, you had conformers. But if you cannot do that, you have configurational isomers. So based on this definition, cis and trans isomers, which type of isomers they are? Exactly. So remember, cis and trans are configurational isomers. Because if I have one chlorine here, one chlorine here, maybe I cannot, you know, convert them to the other unless I break some bond, which I don't want to do here. Any questions? Are we good? And you had also the staggered eclipse structures. I'm going to try to include that when I post the slides. So also study staggered and eclipse, that they were conformers. Okay, so remember those were conformers. Okay, reactions of alkanes. We talked about two types of reactions for alkanes. One of them was oxidation reduction and combustion reactions. The other types was substitution reactions, right? So that oxidation numbers and all that I talked about, I'm not going to ask you in the exam. So what I'm saying is that the oxidation number, so that one I won't ask you, okay? But the rest I'll ask, but I also included them here, so you don't have to worry about them. And remember, for like combustion reactions, you had like, you know, your alkane plus O2 gives CO2 plus H2O plus heat. And this was like the really important part of our class that I'm going to ask you in the exam, so make sure you know. So for substitution reactions, you switch these two atoms. So your methane, for instance, plus, so methane is CH4, right? You switch these two. So you call that CH3Cl plus HCl, and you should be able to name this chloromethane, right? And then one question that I asked you in your homeworks and exam is the complete chlorination. When I said complete chlorination, meaning that if you have CH4 and you have complete chlorination, when this one happens, you can also do that again and substitute another hydrogen with chlorine. You can do that again, and eventually you substitute all the hydrogens with chlorine atoms, okay? And you should be able to name these as well. But in general, this is how to write substitution reactions, okay? And as we said, to save time, sometimes we write the structure, or like, here Br2Cl2 on the arrow, and then here just write the organic compound. So HBr, HCl, these are inorganic because they don't have any carbon in them. So don't get that confused with a catalyst, because most of the time I write a catalyst on the arrow. So if you have substitution reaction, we can also write one of our reactants on the arrow. Questions? And finally, these free radical chain mechanism, make sure to study that the first step is initiation, when your chlorine molecule is being broken to two radicals, chlorine radicals. The second step is propagation, that has two steps itself. You have your alkane form plus one of the radicals, giving like alkyl radical plus HCl, and this alkyl radical plus Cl2, again giving like alkyl chloride plus Cl. And termination step, all the radicals come together and form compounds. So remember, you have Cl2, R2, and RCl. So also make sure to study that well. You're going to see that in the exam. So just ask me if you have any questions. So that was chapter 2 in like 45 minutes.